Howdy, my name is Daniel Van Zant. I'm a computational neuroscientist working at Florida Atlantic University. I have a startup that I'm trying to get funded. I really enjoy drift racing, the sport, so I watch a lot of Formula Drift. And something I've been thinking a lot about lately is limitations of retrieval augmented generation, and in particular ways that I think performance with retrieval augmented generation systems is going to hit a hidden ceiling. Similar to the way that large language models are kind of hitting a hidden ceiling now, and progress is really slowing down in a big way. I think we're headed for the same thing with retrieval augmented generation. So let me explain that a little bit more. There are two flavors of retrieval augmented generation. There is something called embeddings. And so what you do with embeddings is you take a bunch of chunks of text, you throw them all into a hyperdimensional space, and that's a little bit less specific. So let me show you something to show you a little bit more of what I'm talking about. So I'm just going to imagine a two-dimensional space. And we have 4 points on it, like you can see here. So we have 4 points on this space that you can see here. And we sort of have scales, so we can think of this as dogness going up and catness going to the side. And this sort of communicates what the text is about. So we might imagine this bit up here as the cat and the dog fought together. So it's about cats and dogs. This bit here as the dog caught the ball. This bit here as the cat played with the piece of yarn, and then this bit here is neither about cats nor dogs, and so it's something like the man had a beer. So we can imagine these are the sentences, and these are where they would be in this two-dimensional embedding space. So what embedding space for retrieval augmented generation is they do that with like a 1,000-dimensional embedding space, and what I called catness or dogness are what is called features, and those features are a lot more fuzzy. They're kind of defined by the artificial intelligence, but you can think of it along the lines of the same idea. So in some sense, where this is in the hyperdimensional space is communicating what the chunk of text is about, and if it's close to other chunks of text, they're kind of sort of about the same thing. So what you do for retrieval augmented generation, and just so people know what I mean by that, a lot of people have experienced it. It's where you have a document or some set of documents. You ask artificial intelligence a question, and it answers your question, and with the question, it has some sources for the answer. So it's going and looking at those documents and giving you an answer to your question. With embeddings and retrieval augmented generation, the way it works is that you embed the question in space. So you say, for our example, we'll say, how much is this question about cats or dogs? And we'll embed it in our two-dimensional space, or you can embed it in your several million dimensional space or whatever you're using for regular embeddings. It's usually not that high at all, but this is maybe future embeddings. And when you do that, hopefully you kind of cross your fingers and hope that your question is close to the chunks of text that you're interested in, and then you retrieve the closest chunks of text to your question, and you give those back to the large language model, and the large language model uses that to generate its answer. There are quite a few issues with this. There's something called isotropy, I believe. There's something called center collapse. There's the fact that chunks of text can get lost in the center of hyperdimensional clusters. But there's this paper I was just reading, and I think they have a quote that is really good and explains the issue I'm talking about really well. Let me find it here. Introduction of the paper has 2 lines. Line 1, reasoning failures. LLMs struggle to accurately interpret user queries and leverage contextual information, resulting in a misalignment between retrieved knowledge and query intent. And 2, structural limitations. These failures primarily arise from insufficient attention to the structure of knowledge sources, such as knowledge graphs and the use of inappropriate evaluation metrics. So what this means is that any source of knowledge in any document has a kind of internal structure, And when we throw that document with its own internal structure into embedding space, so we chop it up into chunks and we throw it into embedding space and we say, well, here's the features, we get something useful, but we also kind of shred whatever internal structure it had. So like a story has a structure where you have this character and then they have this event happening to them and it's in this location, and then later these characters come to this location and say they see the after effects of this event. Scientific paper has a structure, it has methods and a conclusion and results and an introduction, these kinds of things. So every document has some kind of internal structure, and what you're doing with embeddings is essentially shredding that structure, and that means that no matter how good we get embeddings, which there's even limitations to getting longer embeddings that are effective, but no matter how good our embeddings get, we still have the fundamental issue that we're shredding that structure and throwing everything into hyperdimensional space, and that means that we're going to have reasoning issues with our embeddings, especially on advanced reasoning or retrieving exactly what you're looking for. So there's another approach to embeddings called long context. And so long context is in some ways simpler. So if you don't know how a large language model works, you give it a bunch of text, you say, come up with an answer that finishes this text, you compare it to real text, and you try to lower the degree of error between what the large language model gives you and what the real text would be. And so if you do this a lot, you get something like ChatGPT. And long context is where you do this, but with longer pieces of text. And so essentially, you can just give your AI some amount of documents directly in what's called a context window, or you can imagine in a chat if you're chatting with it, and then it can talk to you about these documents because it just has a very long context window. The issue with that is that as you get to longer and longer and longer context, there's less and less documents available that are above that context. So you can imagine if I go to a library and I say, I want all of your books that have more than 100 words in them, that's going to be almost the whole library. If I say 1,000, I might leave out a few books like children's books, but that's still going to be almost the whole library. If I say 100,000, all of a sudden I'm narrowing it down. And if I say over 1 million, then maybe I'm just left with like a couple encyclopedias or something. And so there's the same problem with training data. And this problem with training data is really important because there's these things called the neural scaling laws, which essentially say that as long as you run out of, if you run out of parameters, training time, or training data, you hit a bottleneck that stops your large language model from getting any smarter. And we can see that the large language models that are long context run into this issue. For instance, even though we have people saying, hey, we have this long context model that works up to 2 million tokens, the performance degrades as the context gets longer and longer and longer. And for most of them above about 256,000 tokens, the performance on most benchmarks is below 50%, and on these same benchmarks at low token levels, the performance is something like over 90%. This is really important for long context because for the two other bottlenecks, which are parameters and training time, you can throw money at it and solve the problem. And there's lots of people that are very willing to throw money at AI right now. But for training data, at the point we're at, the current crop of models has ingested almost the entire internet. And so they've ingested almost all knowledge humans have ever produced. If you're very clever, you might be saying, why can't the AIs produce more data for the AIs? There's some very complex reasons why that doesn't work. If someone solves that problem, you'll create the next AI revolution. That would be as big as ChatGPT coming out. But there's a lot of reasons why people think we won't be solving that problem anytime soon. And so there's not a way to create more training data out of thin air by throwing money at the problem, especially not with long context training data. So for short context training data, you can have pay a human some low amount of money to talk with the AI back and forth, and then you have more training data from a real human. For long context, though, it's much more challenging to pay a human to write like a scientific thesis, and especially at the kind of scale that you need for training data. There's two things, like I mentioned, there's embeddings and there's long context, and these are the two ways we approach retrieval augmented generation, and there's kind of a trade-off here. And the trade-off is, I'm going to say along one axis, and I'm about to show this, it's creativity. So it's the large language model's ability to reason, come up with creative output. Along the other axis, I'm going to put documents. So this is the number of documents that you can feed into your large language model. And you've got a really important trade-off that you have to choose between here. And so we have, so here I can show this real quick here. My handwriting's awful, but you can see there's sort of the long context axis. So you can say, there's the creativity axis. And so if you want documents that are very creative and use high reasoning skills, but you don't have to feed a lot of documents into your large language model, then you would want to use a long context model. If you want a lot of documents, but you're okay if the AI is a little bit dumb, and honestly, you're almost using a glorified search engine, then you would want embeddings-based RAG. And I think I just wrote RAG there. Here, I'm going to rewrite that card real quick and just show it to the camera so you can throw it into the video there. So you can see there's two axes here. There is sort of creative, high reasoning, things like this, but you have low, and then there's the number of documents you have. And there's a trade-off you have to think about here with retrieval augmented generation, which is that if you want things with really good reasoning capabilities, then you have to have only a small number of documents and you have to use long context. And like I said, there's fundamental limitations why the context can't get larger. If you want a lot of documents, then you have to settle for very low reasoning capabilities, and honestly, you're kind of using a glorified search engine and you would want to use embeddings. This is a really important issue because there's a lot of work that happens at this corner up here, which is you need really high reasoning capabilities and you want lots and lots of documents. And so I've actually been working for a while on a solution for that particular box. And I call it a living knowledge engine. And so over here you have high numbers of documents, you have lots and lots of reasoning capabilities, and the way you do this with a living knowledge engine is you create almost like a custom encyclopedia or custom wiki from the documents based around the questions that a person is asking. And it's a fundamentally different algorithm than either of these things. It was actually inspired a lot by plants, because a lot of people don't realize this, but plants have their own kind of intelligence. They can communicate enormous amounts of information to each other. If you ever look at the top of a forest, the trees just narrowly avoid each other and form these really cool fractal patterns. Even fungus are crazy intelligent, even though that wouldn't technically be considered plants. And so plants are extremely intelligent in their own ways. They're really good at building a structure. And so I mentioned that paper before that has that little quote about how embeddings can't work and can't have high reasoning capabilities because they can't structure the knowledge. You shred whatever structure of the knowledge is in the document. But what the living knowledge engine does is it not only keeps the structure of the document, it also forms a metastructure. So if you think about anyone that's ever had a knowledge base, or even Wikipedia is a sort of metastructure over a very large number of documents. So it says, here's this article on philosophy, and here's this subject, and then it relates to deontologicalism versus utilitarianism, and it relates to free will, and then free will relates to artificial intelligence, and none of these articles in here are the actual documents that they're based on. They have those in the references at the bottom. They're a metastructure between all of the documents. And we found that creating this metastructure is really the answer to this issue between, all right, you can only have high reasoning or you can only have large amounts of documents, and you can't have both of those at the same time. So in the spirit of honesty, I get really suspicious when someone says that their solution is just better with no trade-offs whatsoever, because that's almost never true. There are no free lunches. And so in the spirit of honesty, what is the trade-off for our solution? The trade-off for our solution is it takes up more memory than embeddings or long context. But the nice things is it doesn't take up more RAM or more memory on a GPU. It takes up like static memory on a HDD or SSD to have that metastructure. And then there's ways you can sort of query that metastructure and go through it. Those ways are actually faster than embeddings are at a high number of documents, north of around 200,000 documents, something like that. But it has a trade-off. It's a trade-off that we're very okay with because long-term storage like HDDs and SDDs is ridiculously cheap, and it's only getting cheaper, especially if you're looking at the cost for like server space for these types of things. So I'm not going to lie to you and say there isn't a trade-off. There is a trade-off. It's a trade-off that we're extremely okay with. It's a really cheap trade-off, and the trade-off isn't anything that would be important to somebody like the number of documents you can import or your reasoning capability. So we can sort of make the trade-off along this third axis that nobody cares about and solve the problem really nicely that way. I'm really excited about this. I'm also not going to pretend that this is a completely original idea. This idea of sort of a hypertext notebook as a way to form a metastructure over information is as old as the internet. Ted Nilsson came up with a lot of these early ideas. Wikipedia is a version of this idea. Even before the internet, encyclopedias are a version of this idea. We've just taken this idea and integrated large language models with it and gotten those large language models to be extremely hallucination free and come up with a new algorithm to integrate large language models with it so that the metastructure grows itself. And I say grows itself because, like I said, it's much more similar to a plant than it is to any other type of intelligence. And a plant, sort of the cool thing about it is they grow themselves. There isn't any central process. So I really enjoyed getting a chance to talk about this. And everyone here should like and subscribe. This is an awesome channel. There's lots of people smarter than me on here talking about lots of things more interesting than what I've just talked about. So you should definitely like and subscribe so you can see more of that. You can find me on Twitter. You can find my website. You can find my Substack that I want to start posting on very soon. And I'm going to ask for all of those to be in the description, so I'm going to assume they're in there.